Let's work on solving the equation 6x squared minus 3 equals 6x by completing the square. Our first step here is, since there's a coefficient of x squared that is not 1, we'll divide all of the terms by that number to get 1x squared. So here we'll divide everything by 6, leaving us with x squared, and then minus 3 over 6. If we reduce it, we would have minus 1/2 equals x. Now, to use the completing the square method, we need to have all the variables on one side and all the constant terms on the other side. So here, to move the x over, I'll subtract x from both sides, giving us x squared minus x minus 1/2 equals 0, and then we'll add 1/2 to both sides, leaving us with x squared minus x plus a blank space equals 1/2 plus a blank space. So now we can go through completing the square. Remember, minus x is the same thing as minus 1x. So when we take half of -1, we would have -1/2. When we square -1/2, -1/2 times -1/2 is 1/4. So we add 1/4 to both sides. Using our factoring shortcut, we know that when we factor that left side, since we have a -1/2 in that middle step, we would have x minus 1/2 squared. On the right side, 1/2 plus 1/4 is 3/4. Now, we can use our square root property and take the square root of both sides, remembering that when we do so, we would have a plus or minus at the front of the right side. On the left side, the square and square root cancel out, and we have x minus 1/2. On the right side, when you have a square root of a fraction and you can simplify one part of the fraction, it's usually considered good to do so. So the part we can't simplify the square root of 3. We leave that under the square root, but the square root of the denominator 4 is 2. So we'll simplify that and make it square root of 3 over 2. And now to get the x by itself, we add 1/2 to both sides. Those aren't like terms over there because one's under a root and one's not. So we end up with 1/2 plus or minus the square root 3 over 2. And it's fine to leave it like this. Some people, because those fractions do have the same denominator, would write this as 1 plus or minus the square root of 3 all over one denominator of 2. Both of those ways are correct. They're just equivalent ways of writing the same thing. If you would like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. Here, because we have a 2 in front of the x squared, we'll begin by dividing all the terms by 2. This leaves us with x squared is equal to 3x plus 10. Now we want to have the variable terms on one side and the numbers on the other. So next we would subtract 3x from both sides, leaving us with x squared minus 3x plus a blank space equals 10 plus a blank space. To follow our completing the square process now, half of -3 is -3/2. -3/2 when we square it would be a positive 9/4, like so. On the left side, we know that this would be x minus 3/2 squared. On the right side, 10 plus 9/4. 10 is the same thing as 10 over 1. If I multiply both of those by 4 to get a common denominator, we would have 40 over 4 plus 9 over 4, which gives us 49 over 4 on the right side. And now we use the square root property to finish, remembering that when we do that, we put a plus or minus in front of the right side. The square root and square cancel out, leaving us with x minus 3/2. On the right side, the square root of 49/4 is 7/2. Now 3/2 and 7/2 are like terms, so I find it best when you have like terms that you're going to need to combine to go ahead and split the equation up into two, where we would have x minus 3/2 equals 7/2, x minus 3/2 equals negative 7/2. Now add 3/2 to both sides of the first one. 7/2 plus 3/2, we have x equals 10/2, which is 5. The next one, we add 3/2 to both sides. We have x equals negative 4/2, which gives us negative 2.